In section 10.3, we're going to be finding and estimating square roots. A square root is based on the idea of taking a number times itself and trying to find out what that equals. Well, this symbol right here, as you're probably familiar, is called the radical symbol. And the answer to that is always going to come out as a positive number. That's called the principal square root. Now later we're going to do a positive and negatives in other sections later when we're solving equations, but for right now our answer is always going to be a positive number. The number inside, or the variable inside, is called the radicand. And so we're asking ourselves what number times itself equals that number inside that radicand. So let's just look at these simple examples down here at the bottom. The first one kind of thing we say is, what times itself equals 169? Well, 13 times itself equals 169, and so the square root of 13 squared is just 13. As we look at the second one, we have a fraction. And the idea behind a fraction, we have a fraction square root. It's the square root of the top divided by the square root of the bottom. And the square root of 25, as you know, is 5. And the square root of 49 is 7. So 5/7 is our answer. So we can do these problems without using a calculator. Now the next one, as we look, we have the opposite sign in front of a square root. So in your mind, cover up that opposite sign, pretend it's not there. Let's just consider, what is the square root of 144? Well, 12 times 12 is 144. So the answer is 12, and then we take that opposite sign, we're going to put it in front, and so our true answer is the opposite of 12, or negative 12. What times itself equals 0? Well, 0 times itself equals 0, so the answer is just 0. Our next one is somewhat of a creative problem. We ask ourselves, what times itself equals negative 9? Well, let's think for a second. 3 squared is 9. The opposite of 3 squared is also 9. So there's no number that multiplies by itself that equals negative 9, so our answer here is going to be no real solution. It's important to use the word real because there actually is an answer, but that's at a higher level of math that we're not going to deal with as today. Our next problem involves a decimal. As we think of a decimal, we can think of this as 121 divided by 100. Well, the square root of 121, as we learned up here in problem B, we can break it up into two parts, and so the answer to this is 11 over 10, or 1.1. What I'd like to show you is a way to figure out decimals, though, without having to change it into a fraction, and we'll do that on the next problem down at H. But for right now, let's go back to problem G. We're going to cover up the plus or minus, and we're just going to think, what's the square root of 25? Well, the square root of 25 is 5. And then we look, okay, so our answer is either positive or negative 5. That's two answers, either positive 5 or negative 5. And we write it in this way just as a shortcut. Now, on H, I want to show you how to do the square root of a decimal without changing it into a fraction. First of all, we think of what's the square root of 49? Well, that's 7. And the square root of two decimals, we cut it in half, and that's 1 decimal. So very simply, the square root of 0.49 is 0.7. Now I'd like to show you just a number of quick examples that illustrate this idea. Let's take the square root of 0.0009. Well, the square root of 4 decimals is 2 decimals, and the square root of 9 is 3, so our answer is 0.03. The square root of 0.0025, once again the square root of 4 decimals, we cut it in half, is 2 decimals, and the square root of 25 is 5, so our answer is 0.05. I hope you're seeing the pattern. The pattern is you cut the decimals in half. Now, this only works if the number inside is a perfect square. If it's not, you'll have to use a calculator. So think with me. 0.36. It's a perfect square with an even number of decimals. Cut the decimals in half and get 1 decimal, and the square root of 36 is 6. Does this work if the number is greater than 1? For instance, 1.69. It sure does. The square root of 2 decimals is 1 decimal. The square root of 169 is 13. So it's 1.3. Think again with me. Let's look at a larger number. 2.56. Well, the square root of 256 is 14, and the square root of 2 decimals is 1 decimal. I hope you're getting the point, and taking square roots of decimals is a very straightforward process.